Hello everyone, I'm Dr. Vishal Sharma, Senior Lecturer from EIT's Melbourne campus, along with my team comprising of Dr. Akhlaqur Rahman, Dr. Aati Sidpura, Dr. Shasha Bang, and Dr. Deepali Shinde. I would like to welcome all experts, participants, attendees, and other team members at EIT on this fourth Doctor of Engineering conference. This conference is a biannual activity with the purpose of giving our DEng students an opportunity to showcase their work to their peers and other academics across disciplines. It is a great platform to receive feedback and suggestions from other researchers. To begin with, let's pay tribute to our great country, Australia. So we acknowledge the traditional custodians throughout Australia, pay our respect to elders, past, present, and emerging, and extend that respect to any indigenous people present today. Here is agenda for today's first session. This session will be coordinated by me and by Dr. Aarti. In the first session, you will see our Deputy Dean presenting about EIT and DEng program, followed by two expert talks. First one by Dr. Steve, our Dean, and second one from Dr. Amit Agarwal from Amrita University. Thereafter, we'll have student presentations. Now, let me introduce our leader, Deputy Dean Indumathi. It is indeed a matter of pride and honor for me to introduce her. Indumathi, Indumathi brings 2 decades of rich experience as a chartered professional engineer, specializing in electrical and electronics engineering, educational pedagogy, and thought leadership. Her professional journey commenced with a role in failure analysis within Singapore's semiconductor manufacturing sector. Relocating to Perth, Western Australia, Indumathi carved out a niche for herself in the realms of higher education and vocational training. As an educator and lecturer across diverse engineering disciplines, her contributions were acknowledged with the North Metropolitan Trainer of the Year Award in 2017, complemented by her nominations as a contender for the Western Australia Trainer of the Year title. Her academic credentials include a bachelor's degree in electrical and electronics engineering from University of Western Australia, a graduate diploma in adult and vocational education from Charles Sturt University, and MBA from the University of Canberra. Indumathi, a Fellow of Engineers Australia and the Australian Institute of Management, is esteemed for her advocacy of STEM engagement among women and girls. She dedicates herself to mentorship and is currently engrossed in a PhD research endeavor aiming to bolster students and educators using data analytics through EEG technology. Welcome, ma'am, to this session. Now, may I now request you to introduce EIT and DEng program and our team.
Thank you, Dr. Vishal, for that very generous introduction. Hi, everyone. Welcome to our fourth DEng conference. Now, most of you would already be aware of who EIT are and what we do. But just to set the stage for this conference, I will just go quickly over our specialization. So we are engineering specialists, and I think most of you are already aware of that, given that we focus purely on engineering and technology in our courses as well as our specializations. Our programs are industry oriented, which means we take a lot of pride in making sure that our programs have a lot of industry input when we design, as well as while we are delivering when it goes through rigorous quality assurance processes as well. We've got world-class accreditation used with variety of accreditations around the world, both, for example, with TEXA, ASQA in the Australian government, as well as with Engineers Australia as an industry body. And that means you're having international recognition for most of our programs due to mutual recognition agreements within the accords. So we have the Dublin, Sydney, and Washington Accords. And as you would see here as well, in today's presentations, as well as during your course and research, you would see that we've got access to a variety of industry experienced leaders. So it's not just pure academics who are in the academic field, but we've got people from the industry experienced with what is going on in the industry and the problems that they are facing every day, bringing that education and knowledge to you in your programs and your research. Our delivery model is unique, and as you can see, one of the reasons we are from different parts of the world able to join together here to discuss, go through our conference is because of our unique delivery methodology. And students have access to remote laboratory simulation software, as well as state-of-the-art learning management systems. I just want to quickly go through the core structure of our program as well. Again, this is actually beneficial for students who are in the initial stages of their doctorate program, who may not be quite aware of the complexities or the options they have within the DEng program. So if you're doing it full-time, you've got options for doing it in 3 years. And if it's part-time, of course, the program duration extends depending on the workload you undertake. Given that it's a professional doctor of engineering, it's comprised of 1/3 of coursework and 2/3 of research. So what we aim to do is to provide some structure with the coursework units, preparing students to be able to undertake research, as well as gain the breadth of knowledge that they need for their specific specializations. So you've got some coursework units, as you can see in year 1 or term 1 and 2. Followed by some research work. So we always try and keep mixing some research with the coursework. My general advice to students would be, even though you may be participating in coursework, don't stop your research, your literature review. Please continue that on the side so that your research can be developing as you go. There are a couple of units that you may need to be aware of, which would be your elective units. So you have option of elective units in DEng 801 and 803, as well as, if I'm not mistaken, in DEng 603 as well. So what that means is, to expand the knowledge of your specializations, you can undertake or you can choose electives from a master year 2 level unit to complement your research. Now that does have an application process, but that option is available for you. We also get students to complete the doctoral dissertation research paper 1 and 2, just to get you into the writing and be able to submit to journal papers before you complete your final dissertation. It's full-time again, it's over a period of a year, or if it's part-time, it will be extended as well. So again, setting you for success using structured coursework and research units as well in our programs. Just want to quickly introduce our faculty in terms of supervisors. Now, these are just the key supervisors we are introducing here today. We've got a lot more supervisors that may not be mentioned here, but we have a good list of supervisors in different disciplines. For example, we've got Professor Akhtar Kalam, we've got Professor Asad, Professor Vidyapeetham, Professor Zubair, Professor Daniel, and Professor Mehran. So they come from different parts, different universities within Australia, but they are also supervisors for our doctorate students, and they are from different disciplines and bring their research expertise to guide our students in their research. In terms of our internal, actually continuing with our supervisors, we also have Professor Vimal, Professor Ahmed, Dr. Eshan, Dr. Mochaba, Associate Professor Kurosh, and Dr. Vincent Wang. Again, if you can see, they come from different schools. We've got mechanical, civil, electrical and computer engineering, and so on. So we've got, again, a broad range of supervisors assisting you with your research and presentation. Arthi, am I passing this over to you, or would you like me to introduce Dr. Vishal for the next section?
I think you can continue with Vishal and internal staff, and then perhaps I'll take over.
Yeah.
Thanks.
I would introduce you to Dr. Vishal, who started the session. So Dr. Vishal has over 25 years of experience in both teaching and research, and has international experience publishing over 117 scientific articles, and with a total of over almost 4,000 citations. Now, he's listed as among the top 2 researchers as per Stanford study, and we are very pleased to have him on our faculty list. He's worked at France, South Africa, Norway, India, and has international research collaborations that are ongoing as well. He's associate editor for highly reputed journals, as well as he supervised multiple PhD and master students. He's not new to organizing conferences, so this year's conference organized by him and Dr. Arthi would be something to really look forward to, and I hope all the students who are participating here and staff participating here would get a really good experience. Sorry, I think I've lost the slides. Dr. Vishal, where are you sharing it from your end? While we're waiting for the slides, what I might do is also introduce you to our internal staff. So we've got Dr. Vishal, who is our doctorate program research and course coordinator. So if you have any issues with your academic questions regarding doctorate program, he will be your first point of contact. Next, we have Dr. Arthi Sidpura. She's been teaching with the DEng program, and she's been EIT with many years, and she is a course coordinator and lecturer at EIT. She's also associate supervisor for many of our doctorate students. We've got Dr. Anna Evangelista, again, course coordinator and lecturer from civil engineering. Again, comes with a lot of experience and been supervising students in bachelor's, master's, and doctorate as well. We've got Dr. Harrison Palmer, background in process and chemical engineering. Again, he's our lab coordinator, but also associate supervisor for some of our students. Dr. Milind Sidhupura, course coordinator and lecturer from mechanical engineering. And again, once again, he supervises many of our bachelor's, master's, and doctorate students. Dr. Yuan Fan from School of Electrical and Electronics Engineering. And again, she's course coordinator and lecturer and supervisor as well. These staff here that I've just mentioned are based in our Perth campus in Western Australia. And we also have Dr. Sasha Wang from School of Civil Engineering and Dr. AK from School of Industrial Automation based in Melbourne. And again, they are some of your faculty and supervisors that you will see throughout your course. The next few, again, these 4 staff are present in Perth campus. We've got Dr. Arvind from School of Mechanical Engineering, Dr. Deepali from School of Industrial Automation, Dr. Igor from School of Civil, and Dr. Hussain from School of Electrical. Again, you can reach out to any of the faculty if you have any questions or if you want to talk about any specializations. You don't have to limit yourself to your supervisor and associate supervisor, but as a courtesy, I would like you to go via Dr. Vishal before you contact one of the other staff who are not your supervisor or associate supervisor. And with that, I will pass it over to Dr. Arthi. Or back to you, Dr. Vishal.
Okay, no problem. Thank you so much, Deputy Dean, for introducing EIT, DEng program, and all team members. Now, may I request Dr. Arthi to step in and continue with the proceedings of the conference. Dr. Arthi, please.
Thank you very much, Dr. Vishal. Just quick check on audio. Can you all hear me?
Yes, we can hear you.
All right, great. Thank you. All right, so it is with great pleasure that I welcome you all to this 4th Doctor of Engineering conference at EIT here. This is just the agenda of the conference. As you can see, various different sessions. So we have 4 keynote speakers. We are having these 2 speakers today, and then we have a couple other in the afternoon session, and then we have 1 more keynote speaker coming up for tomorrow's session. We will have 2 more workshops coming up tomorrow for the session 1 and session 2. And then there are 3 DEng student presentation sessions where students will be presenting what they are working on. And there is also 1 session on poster presentation. So that's about the conference and overall plan of the conference. Moving on. So our first keynote speaker is Dr. Steve Mackay, and let me introduce Dr. Mackay. So we are honored to have a visionary leader among us. someone whose commitment to engineering education has not only shaped countless careers, but has also propelled the field into new frontiers of innovation and excellence. Now, please allow me to introduce Dr. Steve Mackay. Dr. Mackay is not just the founder of the Engineering Institute of Technology, but he is a trailblazer, a pioneer, and a true champion of education. His unwavering belief in the power of knowledge to transform lives echoes the timeless words of Nelson Mandela. Education is the most powerful weapon which we can use to change the world. Now, with over 35 years of experience in the field of engineering, Dr. Mackay's journey has been nothing short of extraordinary. From automation to data communications, from power stations to petrochemical plants, he has left an indelible mark on industries across the globe. Dr. Mackay's influence extends far beyond the confines of the classroom. He has shared his expertise with over 30,000 engineers and technicians worldwide, delivering courses for esteemed organizations such as NASA, Rolls-Royce, and BP. But Dr. Mackay's contributions don't stop there. He is also a prolific author. With 25 engineering books to his name, each one a testament to his dedication to knowledge dissemination and academic excellence. As a fellow of Engineers Australia and a chartered professional engineer licensed in chemical, mechanical, and electrical disciplines, Dr. Mackay's credentials speak volumes about his expertise and commitment to the highest standards of professionalism. So it is my distinct honor to present to you this inspirational leader, an esteemed educator, and a true advocate for engineering excellence. Please join me in welcoming Dr. Steve Mackay.
Thank you very much, Dr. Arti, for your intimidating bio. I don't recognize it. A bit embarrassing, I think. Probably at the end of the day, the most important thing is in any organization, surrounding yourself by people who are considerably better than you. So fortunately, I'm in that position. So I struggle on a daily basis to do too much, and I'm really grateful to be here. So I've got a short presentation on AI, and we've got an intimidating bunch of presentations who are probably considerably better than mine, and hopefully I don't get found out over the next 45 minutes. So really just want to say a few words about AI and engineering, and if I can just really, I think one of our biggest challenges today is obviously the issue with population growth, pollution, climate change, and these are going to be great challenges for us coming forward. So I'm hopeful that AI may help a little bit. And obviously a huge thank you to my colleagues at EIT. As I said, I'm always marveled at the incredible prowess, drive, enthusiasm, and it's always very enthralling to be with such a wonderful team of people. And obviously a huge thanks to Dr. Vishal Sharma, and obviously Dr. Arti as well, for arranging this useful conference. I hope it really goes well. So really, what I want to do today is just quickly summarize the objective, talk about AI very briefly. I'm sure everyone's probably a little bit over AI. You probably hear so much in the press. I just really want to talk about one of the key building blocks of AI, the transformer model. And then also highlight the teaching with AI, which I think you've already had exposure to these really incredible academics from the US who have written quite a bit about teaching with AI. I just want to mention a little bit about that. And then finally, just reflections of AI and engineering. And this is really, this whole presentation has been driven by a whole series of lectures or tutorials we did around Southern Africa last year and online, and I had a huge amount of responses from people, and it's the usual thing when you're presenting these sessions. We had probably over 1,000 people last year attending these sessions. The thing about these things is that you learn so much more from the attendees than you actually know yourself. So it was a really great learning experience for me. So I really just want to do meander a little bit about it, and obviously, as I say, focus on a transformer model, teaching, and engineering and AI. And I suppose one of the great things is you will find that we've got a lot of problems, but I think they're really opportunities. And AI won't fix the problems, but it will probably act as a useful tool. So hopefully by the end of the presentation, we'll have a discussion about that. I suppose before I go any further, I just want to confirm everyone can hear me okay. Can you please just give me a little tick in the box that, hello, Steve, I can hear you, or no, you breaking up terribly. Thanks very much. Thanks, Dr. Anna and Dr. Indu. Thank you very much. Marvelous. Okay, that's fantastic. So I suppose the first question I want to ask everyone here now, and Garth in Cape Town is here. I had a happy coffee with him earlier last year. I'm sorry it's so early for you, Garth. I just want to ask everyone here to put in the chat box what they think AI will do for engineering. So just give me a little summary and let's have a little kick off the discussion. Just compose a few words, just one or two sentences, how you think AI is going to impact on your life in engineering. So just put some ideas down, and then we can come back to those once I've started chatting. So I'll be chatting now, but please just put some stuff in there. So first of all, AI, just to quickly make sure we're all on the same page. You've got the usual summary of AI here, AI over here, and then you've got machine learning, which is probably what I used to refer to as multivariate statistics when I did the course presented by that incredible guru at UWA, Professor Jeff Souter, who was an incredible guru. I did it 20 years ago. And then a summary of that is deep learning. So I'll obviously focus on the deep learning part because that's a critical part. Machine learning is useful, but deep learning is probably going to be the main driver. And really, the basics of machine learning is, as you would realize, is training. So you take a lot of data, you train it using an algorithm, and then when you get new data, you can then make a prediction about data. So for example, you could say the demographics in Western Australia for housing, who is buying housing or who's buying a home, who's putting pressure on housing prices, are things such as international students, increase in international students, lack of builders going bust, liquidations of housing construction. So you can actually have a whole lot of impacts. And then the idea with machine learning is you can then make some nice predictions going forward as to what's going to happen in 2024. So machine learning is obviously something we've used extensively, particularly with multivariate statistics. I'll come back to those comments. Thank you very, very much. I just want to quickly run through neural networks. So really probably the biggest driver for our AI work is neural networks. So just to make sure we're all on the same page with neural networks, as opposed to just multivariate statistics. If you've got a number 2 like this here, you want to obviously, you've got someone who's scribbled it out in very average bad handwriting, and you want to obviously work out what this number is. If it's a 9, 2, or 3, and you then have what we call neural network looking at each one of these little dots here, and then hopefully being trained to actually identify what this number is. So someone's drunk and scroll like that, hopefully you can identify that it's a 2 using a neural network, which looks like something like this. So you've got all the numbers coming through, and you've got a network looking like this, where you've got your inputs, each one of those pixels, and you've got little weights, and you then come up with a output, and you'll say, hey, it's actually a 2, and you can then predict it. There's also a bias which you put in. Now these weights are trained using techniques such as backpropagation, and you train it up, and of course your neural network is then able to identify digits with high degrees of accuracy, probably far better than traditional machine learning. And you get some sort of formula like this, and of course that's the basis of a neural network. And the critical thing is that this is trained, and these weights are constructed. And this is obviously the genius behind a lot of the AI today, and particularly the stuff I'm going to be talking about. Now, there's been a whole lot of sort of activities with neural networks, but probably the most critical driver has been this thing called a transformer, which is what I want to spend a few moments considering before we go any further. But before I do that, I just want to actually look at the comments we've had from everyone here. So we're going to come into transformers in a tick. I just want to look at everyone's comments here, and let's have a look. So how do we see AI impacting on us? Beside hearing, I'm just having a look at all the comments here. Propel innovation, yep, as Indu says, innovation, efficiencies, more efficient, thanks Yan Yan. Productivity, create efficiencies, store data more efficiently, productivity, yep, project management and sport analysts involving huge data. And that's quite true. In fact, talking to a family friend last week who's a programmer in London, he's pretty skilled in Python and C and everything like that. And he said to me, Steve, you know, we used to have 4 or 5 programmers writing stuff. We've now reduced down to 2 programmers because a lot of the stuff I do, I just put it out to ChatGPT, and it actually corrects my snippets of code, and I actually produce a lot more. So certainly productivity and efficiency has increased dramatically in an area which I would never have thought about, which is, of course, programming. I always thought that was a very creative area, and I thought that would be the last thing that AI would touch. But certainly it's created huge amounts of efficiency, and there's also predictions that's probably one of the main reasons why there was a sudden shake-up last year in employment of techies, geeks, and programmers, because all of a sudden you've had this amazing tool to actually help you do things a lot better and quicker. Now, one of the big drivers is transformers, and I suppose I don't want to sound dismissive of AI, and I'm certainly personally putting a lot of effort into getting up to speed with it and trying various items to learn using Python and looking at various engineering scenarios. So I've been doing quite a bit in this area, mostly unsuccessfully, I might add. But I just want to talk a bit about the transformer part of the AI hierarchy. So you can look at this document here, and this is probably out of a paper, the model architecture, and it's a very famous paper. It was released about 4 years ago now. And I just really want to reflect on some of the aspects of transformers, which has made a huge impact. Now, I know in 45 minutes, I'm unlikely to be able to go through all the intricacies of this. It normally takes a few hours. So I just want to touch on some of the critical issues of transformers, and then obviously relate that to what I'm going to talk about later. So don't get confused. Don't worry too much about the charts. I really want to just talk about the input embedding, multi-head attention. This thing called attention is really important. Feed forward, and then just look at softmax, the output, and just said really just look at some of the critical parts of this transformer model, which is what's totally made ChatGPT a hugely successful model, as well as a lot of its competitors. I suppose one of the disappointing things about the model, the transformer model and the ChatGPT, is that we spent a year, the guys spent a year putting together the model, then training it up over a year. And it's basically gathering information off the internet, which is obviously fraught with lots of gibberish, lots of drivel. You only need to look at the massive outpouring of commentary on Mr. Donald Trump, who's going to trial today, and to see a huge amount of misinformation and stuff. And of course, that's all taken as gospel, as truth. And of course, you've then got to try and dissect truth from the reality, the truth, the real truth. And there's another 6 months typically taken to retrain the model with humans. And again, that's a huge amount of work. But let's have a look at some of the aspects of the transformer model. And there's a really great guy from the site I've taken these slides from. But I really want to first of all talk about the attention. So the first point is that input embedding, and I'm going to jump through the slides. One of the most amazing things, as Mr. Sharma says, one of the most amazing things is that all these AI models, we think about words we have, and they're adding words in and they're thinking of words. In fact, no AI tool, ChatGPT, has ever seen a word in its life. It doesn't deal with words. It purely deals with numbers. And that's a bit distressing when you think that all this analysis is just done purely on numbers, in vectors, matrices. And that's a little bit distressing when you see all the volume of words that are coming out, but it's all based around numbers. So the AI tools only see numbers. So the first thing is the inputs that we have, the input embedding that comes in. The first point to make is that every word, we have a vocabulary. So we have, say, 50,000 words in a vocabulary. So they all have unique words, and 50,000 is a pretty standard number of words in a vocabulary. And every one of those words has to have a vector representation. Could be, say, 500, have a vector representation. Could be, say, 512 numbers. So every word is represented as a vector, and that is the input embedding. And you have things such as word to vec is one of the probably the more famous, well-known algorithms. So every one of these words is created into a vector of 512 numbers, which is how our wonderful AI tools work. 512 numbers, or maybe 1,000 numbers if you've got a very extensive vector. And this is the tool in which we work. Now, the problem is these vectors, and if you look at a space, a vector space, three-dimensional space, you have these words in the space. Obviously, with 512 dimensions, I've only simplified it to 3 dimensions here, but with 512 dimensions, you've got a considerably more complex vector space. And the idea is that every one of your words in this space are grouped together. So for example, apples and oranges are in the same sort of area in 512 dimensions. And you'll find computer firms such as, say, Microsoft, IBM are over here. And of course, the biggest challenge, as those of you in the know would realize, is that if you have an apple, which is something that you eat, versus an Apple computer firm, you've got a problem. Where do you put that particular element? So we've got these 512 numbers representing Apple, but where do we put it? Do we have it over here or over here? And of course, that is where the breakthrough was with the attention part of this model. And it's quite ingenious, actually, how they've put together the way of working out how to identify and solve this problem. Because before, every word was completely clinical and disconnected from every other word. So for example, if you write a sentence, excuse me, if you write a sentence, the bear ate the bear walked across the road and it was. So if I write something like that, the bear walked across the road and it was. And I'm looking for a word here. So the idea is that with the AI model is we've got all these wonderful representations, and every one of these words has a vector representation, a set of numbers. And as I said, the AI tool does not see words, it just sees purely vectors, numbers. And the problem is when you are creating the sentences, if you look at a sentence here, you may say, this it here, where do we put this? So I've spoken about apple being over here or over here. You've got every word in this sentence here actually has a relationship with every other word. So attention is where the brilliant breakthrough was to say, hey, every word here has a context. So we can't just simply put a vector representation there. We actually need to refine that vector notation and actually move the word or the vector representation to another location. So for example, apple here, we would, in the sentence, we would say, I bit a apple. Well, obviously that is a real apple, whereas I have a Apple computer, that would be a totally different one. So what we would do is take this vector representation of Apple and we would move it. If we said an Apple computer, we would then modify that vector representation to be closer to the computer world there. Whereas if I bit into the apple, we would modify apple and move it to over here. And it's the same thing with a sentence like this. The bear walked across the road and it was. Well, we need to obviously understand what it refers to. Does it refer to the road or does it refer to the bear? And again, we can actually build up a relationship between these depending on what word we end up here. Was blah, blah, blah. We can then build up a relationship with every one of these words by the context in which it is. And this is all part of attention. So that is really an important concept, that we modify the words, the vector representation, by the actual context. And that's attention. And that was the big breakthrough. and that has made a huge difference to the interpretation of words. So this is all the context, self-attention, and this is this key building block of the AI tools. And of course, the feed-forward neural network is the standard neural network, which I've described earlier on. But the idea is that we can then refine with multiple blocks, we can then refine the actual representation of every word from what it was originally in a vector representation using self-attention. And that's probably one of the key building blocks of the transformer. Before we had attention, we had problems, and we had really weak AI tools. Now we have a very powerful one. So I think I've run through that enough. The problem also is that with self-attention, we actually do a lot of matrix manipulation, and we have three parts to the self-attention. We call them queries, keys, and values. So we actually transform the initial vector using queries into queries, keys, and values. And again, that's all part of the actual process of giving that context, which we didn't have before. And we calculate a score. So I'm not going to spend too much time on that, just to self-attention. And this is obviously the detail. One of the biggest challenges with manipulating the actual initial vector, as you would understand, the original vector, is that we actually get some massive changes in the actual number values. So for example, you could end up with 0.001 here, and then 1,000 here, and 1 here, and then 1,000 here. And we need to often rescale them, and that's where we do quite a lot of rescaling through the actual process of manipulating the actual original word value. So there's a lot of scaling that has to go on to try and avoid it getting too out of kilter. And then this is actually converting from one language to another, which is one of the applications of AI tools. So in essence, what I was trying to drive there is that the attention, self-attention, attention is a critical part of the model, and that has made a huge impact. Before we had attention, we had some fairly average results. And of course, now we have the transformer with attention as a critical building block has made a huge difference to ChatGPT. However, and this is perhaps the disappointing thing, and I just want to obviously quickly run through some of the aspects of ChatGPT. Obviously, you're all using it or using the equivalent version on Google or on Microsoft. Prompt engineering, there's a whole lot of tools there. The most important point that came out of the discussions last year is that if you can't check your results, if you don't have the skill to check the results, you will be gravely disappointed with AI. So always use a human, an expert, to actually check the results. So don't use ChatGPT to come up with magical answers which in areas where you have no idea, because you will be gravely disappointed, as I'll come to in a tick. Avoid using sensitive or private data, because you can bet your bottom dollar it's going to be circulated. And obviously the idea is that ethics is a critical part. And obviously there's a big question mark as well. And I'm sure there's probably some discussions there. In fact, let me ask everyone here, how does everyone think legal ownership will play out with AI? In other words, let me ask the question, do you think we should allow AI tools to simply trawl the net the internet and grab data, or should there be some restrictions? What does everyone think? There's a few court cases playing out at the moment, and I think there's going to be some issues, but obviously certain parts there. What does everyone think? There should be regulations, as Yan says. Yep. So certainly there's a big problem at the moment because lots of authors are saying, hey, you've taken my data and you've now putting it out there. And artists who've drawn pictures, music, saying, well, hang on, my song is actually, I can hear my song played out here. So there are some big challenges. So there's going to be some restrictions in due course. And it is a real challenge for us as academics or as teachers with the materials we got. It's a very gray area in terms of ethics. We need more regulations. So there's going to be a problem there. And obviously there are going to be certain countries who say, who cares? I don't care about restrictions, I'll just do it my way. So there are some potential issues that are coming out of this. So as Anna says, Dr. Anna says, a long journey to get better laws and regulations regarding privacy and ownership. Yep, that's a big issue. Now, I'm going to come to some examples of AI in engineering, and I just want to obviously just say, it takes typically a year to actually train up your ChatGPT using automated processes, and then another 6 months with humans. And you'll be horrified. You'll be horrified at the amount of retraining, or what we call, what the purists here refer to as, let's call it fine tuning. It's a bit of a, is the term used, fine tuning, for humans to come through and clean up the mess of the AI tool when it's actually gathered all this information off the internet, to retrain it with fine tuning. And again, using humans to actually clean up. And you probably, if you're very sharp and you ask a particular question, you can sometimes see, I believe you can see, a answer from ChatGPT which is a human response rather than one it's gathered just randomly off the internet. And the humans are pretty critical in training this animal up to do a good job. You'll be quite horrified how important it is. So there's a lot of talk about it just purely being done with software, but the human is absolutely critical in the actual training. And it's actually quite horrifying how important they are. And you've probably seen the case recently. There's a bit of a legal action with the Kenyans. I believe a whole lot of Kenyans, thousands of Kenyans are used to do a lot of the fine tuning, humans, and some of them are pretty distraught about some of the filth and the horrible stuff they've had to contend with from the internet. There's some pretty diabolically nasty stuff there and some pretty bad stuff. So some of them have been pretty traumatized with the retraining, the fine tuning. Now, these two, I just want to mention, Ethan Mollick and Lilac Mollick have done some amazing things with education. And I think Indu has already put up some stuff on this. We've already been discussing, they've already done some really great things. From University of Pennsylvania, some really worth watching their videos, really good stuff. So I just want to make sure that everyone's across these guys. They've got some really good lesson plans where you actually get ChatGPT involved in helping you, and they've got some really good examples of how you can apply it. Come up with lesson plans. So this is some of the, should we say, the prompting that you use for ChatGPT or another one. To, you're a friendly and helpful instructional coach helping teachers plan a lesson. So it actually gives a whole lot of instructions to create lesson plans. There are some problems with engineering, which I'll come to, and I'm sure Dr. Igor will look at this with a frown on his face. There are some problems, which we'll come to in a tick. Create effective explanations, examples, and analogies. You're a friendly and helpful instructional designer who helps teachers develop effective explanations. So again, training ChatGPT to come up with some useful explanations and some really good stuff here to use. Help students learn by teaching. And then the final one is example D is create an AI tutor, which is something which we in our wisdom are trying to set up with some of the certificate courses, because I do think it has got some opportunities here. You're an upbeat, encouraging tutor, lovely words, who helps students understand concepts, blah, 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 and wait for a response, and then give explanations, examples, analogies. So really a good prompt for a tutor. And again, there's some good stuff that goes on here. So definitely worth watching these videos of Mrs. Doctors or Professors Ethan Mollick and Lilac Mollick. Forgive me if I've mispronounced their names, but they are absolutely, they've done an outstanding job. University of Pennsylvania, I think it's the Wharton School of Business, which is a very good MBA program. Even though it's business, it does apply to engineering as well. Now, I just really want to spend the last few minutes, and forgive me for talking without interacting as much as I would like to. I just want to reflect on AI and engineering applications. So what we did on this roadshow is we gave 5 different scenarios. Civil, I'm not a civil engineer, but I stuck my neck out. We did a road design project, pumping water. No cement, Dr. Anna. Unfortunately, I didn't take too much of a risk trying to do cement. But what we did is we tried to focus on local applications. In other words, with the road construction, we said use local materials in the Cederberg Mountains of the Western Cape of South Africa, or use a road construction in Meekatharra using local materials. We did a electrical one, which is a fairly standard one, which is a solar panel design on a roof of a building in West Perth. No surprises where that came from. And we also did one on my particular area of interest, which is to do with control and instrumentation. So I suppose the question I've put here is fairly generic. A pump station, a pump seawater at a rate of 400 cubic meters per hour into a mineral processing plant of the coast of Sperrgebiet is German for the forbidden area. It's got lots of diamonds. And then detail the control and instrumentation strategy be required to control this pump station. And then actually have a look. So what I would like to throw open to people here is one of the obviously the results of this, the tool came up with something fairly specific. Here's some of the suggestions: flow measurement, pressure control, safety and protection. So it's pretty detailed. Communication integration, redundancy and reliability, and it came up with some very specific stuff, protocols, blah, 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 which was quite useful. So it was quite pleasing to get that. But can anyone tell me what was the biggest drawback from the actual design recommendations from ChatGPT? Can anyone type in the box there, or even take the microphone if you want? What are the biggest challenges we had, which everyone eventually commented about, we try to deal with? Put it in the box. Just chat in the box if you want, or you can even talk. What do you think? What are the biggest challenges? Project constraints. Yep, Mohammed, thank you. That's not a bad one. So certainly the project constraints, the restrictions, probably we didn't define clearly enough, so that were certainly What are the other issues with the ChatGPT tool? Local conditions. Yeah, as Dr. Vishal says, one of the biggest challenges with the ChatGPT model is that it comes up with some lovely stuff, up to date with standards, specifications. Absolutely. Thanks, answer. That's really good. Human factors, environmental conditions, hazardous areas. Yep. Unfortunately, you're quite right. So what I found, which is quite fascinating actually, is that you can drill down and you can start quizzing it in greater and greater detail. And I must say the groups that we had civil engineers, we had mechanical engineers, electrical engineers, they all went berserk. They all got into the tools and they started asking some specific design questions. I mean, the guys in Botswana said, okay, what are the local design conditions? Unfortunately, the ChatGPT, probably the best scenario, the best solutions came up with the solar panel design. Certainly the solar panel design was pretty well done, because the solar panel design in North America and Perth, there's a huge amount of similarities. But when it came to local conditions of a road in the Cederberg, it said, "Whoo, I give up. I cannot give you the answers." Or worse than that, it came up with complete gibberish answers, use this and this type of quartzite rock, which wasn't even in the area. So again, we needed an expert to be able to say, hang on, no guys, that's not a good answer at all. So when it comes to general project management stuff, European or American centric, it comes up with good stuff and you can probably live with it. You know, some useful stuff, general design, fairly useful. But when it comes to the specific application on the site, it is clueless. I hope it will improve, but it's going to have to do a huge amount of work. It's going to have to be indoctrinated, taught of the local standards. There is a huge amount of stuff there. I'm not sure whether in the next few years it will have that. But I can see people in Perth, for example, Dr. Anna saying, hey, I'm going to set up a business providing a ChatGPT solution for everyone in Western Australia using local standards, using my contacts to teach a tool, which I will then commercialize, teach a tool to provide you with specific information in this area. But am I going to release that to the world? No, I'll charge for it. So I think certainly you will see that. And as Dr. Aravind says there, the recommendations are fairly generic at this stage, too general. So I don't think at the moment we have any threat to take our jobs. Certainly if you are, Dr. Aravind decides to open a rock and roll band, engineering rock and roll band, I'm sure ChatGPT will steal these songs and will reproduce them and you won't have a job in that area. But in engineering, I think as long as we specifically focus on general solutions, we're going to get good answers from the ChatGPT models. But when it comes to specific applications in the area, highly specialized, highly creative, I think we've still got a good opportunity as engineering professionals to provide solutions there, which is good. So that is probably one of the most distressing and most prosaic results from the roadshow last year. Some of the attendees came up to me after and said, hey, I'm a bit disappointed, Steve. Surely you can get the AI tool to do more than this. You know, I was thinking it's going to do my job. And I had to say, look, unfortunately, it doesn't have the detailed knowledge of the local conditions in Port Louis here in Mauritius or in Gaborone in Botswana or in Windhoek or whatever, or even in Meekatharra. It still has to learn, get that information, and whether it does, I think the jury's open. But certainly if you're doing a generic financial business application, give me a financial structure for a company, I would say that it would come up with some pretty good answers there. but anything highly specialized in engineering, it's still got a way to go. So that is probably a no-brainer answer, as you'd expect. The stuff it's come up with here is useful. It's not stupid. It's not bad. But again, a lot of the points here, I would also say, are nuanced, and they do require a little bit of interpretation, which is where you as an engineering professional come in. So I just want to thank you very, very much for everyone's interaction. I'm sorry to talk for so long, and it's a really enjoyable area. I must confess, I've learned a lot from Data Camp, and obviously this AI and machine learning has got a huge opportunity, I think. And I would urge everyone here to go out and commercialize their knowledge with a tool which you can commercialize using this tool as a basis in your area of expertise. I think there's a huge opportunity there. Whether the ChatGPTs of the world are going to be able to go down to the nitty-gritty area, I'm not sure at this stage, certainly not at the moment. So thank you very much, Indu, for coming along, and thank you very much, everyone, for your comments. Any final comments before we wrap it up? I'm sorry to overshoot on time again. My apologies, the organizing team. Any comments, questions, points you'd like to make?
Thank you very much
I'll
for...
pass it over. Thanks, Dr. Arti. Over to you.
Sure. Thank you. Thank you very much for sharing your reflections and experiences from this lecture tour. And also on AI implementation in South Africa. Yeah, I can say that it's quite evident that AI holds immense potential for transforming engineering practices across different contexts. Any questions, anyone? In the meantime, Dr. Mackay, I would just quickly would like to ask you something. So from your interactions during this tour, did you come across, or would you like to highlight any compelling or unexpected insights during this tour that you might have gained regarding adoption of AI in South Africa?
Very good question, Dr. Arti. What I really found initially quite daunting was we provided, just on a purely technical, very laid-back note, I was a bit, we were a bit disappointed because we had to provide computers to people initially, and some of them didn't work and some of them did work. Eventually, we found out that one of the best ways of you can get a pretty good result just using your phone. So you just go into AI with your phone, and you can actually get some pretty good initial commentary and results by getting groups with their phones, and you can get some pretty good insights very quickly just using your phone, and rather than going for high-tech computers and stuff like that. So that was the one thing. And the second thing is, I can't express enough, one of the challenges is when you've got a group of 200-300 in a group and you're trying to interact with them, this amazing tool of actually putting the barcode on the screen using Kahoot and then getting everyone to scan it in with their phone, and then they can respond to interact. You can interact with 200 people. I mean, it is miraculous. And using Kahoot, I can't tell you enough how powerful it is. You interact with people in the audience with their phones, and you're doing a presentation, and you can do it there and then, and you can have bar graphs on your screen. It's just miraculous. It's a wonderful way of livening up a presentation, and it was very enjoyable being able to do that. So that's all from me. Thank you very much, Dr. Arti, and thank you very much, everyone else. And thank you very much, everyone, for getting up so early. I apologize. We should run the session a bit later.
Thank you very much, Dr. Steve. And yes, I do agree at times phones may not seem like quite powerful when it comes to handling lots of data and all those things, but yes, they come very handy and they are really reliable machines. All right, so let's move on with the next keynote speaker session. So we have Dr. Amit Agarwal presenting the second expert talk. Let me first introduce Dr. Amit. So we have the privilege to hearing from this true Renaissance individual, someone whose expertise spans the realms of academia, industry, and entrepreneurship. Now, please join me in welcoming our second keynote speaker, Dr. Amit Agarwal. Dr. Agarwal is not just a professor, he is a visionary and a catalyst for innovation in the field of cybersecurity and electrical engineering. With a PhD in electrical engineering from Nanyang Tech University, Singapore, and an MS in financial mathematics from the London School of Economics, Dr. Agarwal's academic journey is as diverse as it is distinguished. But Dr. Agarwal's expertise extends far beyond the ivory towers of academia. With 12 years of experience in banking, including roles such as risk modeling analyst at Standard Chartered Bank, he brings a unique perspective to the intersection of finance and technology. As a technopreneur, Dr. Agarwal has not only embraced innovation, but has also helped shape it. As the founder of Koyo Software Solutions in Mumbai, India, he has led initiatives in cybersecurity, digital agriculture, and mentoring technology startups, leaving an indelible mark on the industry. At Amrita, Vishwa, Vidyapeetham, Dr. Agarwal's passion for teaching and research shines through. Whether he is educating students in basic electronics or delving into the complexities of machine learning, his dedication to fostering the next generation of innovators knows no bounds. So it is my distinct honor to present to you a scholar, an entrepreneur, and a true visionary in the fields of cybersecurity and electrical engineering. Please join me in welcoming Dr. Amit Agarwal. Over to you, Dr. Agarwal.
I guess you can hear me now. I'm not
Yes.
sure whether you can see me. Let me just make sure about that.
Yes,
I
we can
think
see
you're
you
able to
now
see me
as
now.
well.
Okay, and one last thing, which is getting the screen board ready here, and then we'll be into our talk.
All right, so you would like to share from your screen?
Yes, I will. Yeah.
Okay, so
Okay, it does that. Okay,
yep,
great.
perfect. We can see.
Well, thank you, everybody. Thank you for coming in here and having me here to speak with you. This is the second time I believe I'm having the privilege of speaking with people at EIT. We just saw a wonderful presentation on an area uh, which is searching for information, ChatGPT being the pinnacle of that these days. So this application of AI. Now we're going to talk about application of AI in a slightly different field, which is digital agriculture. And we're going to motivate it with some examples as to why there is a need for AI, where the problem fits in. And then we'll proceed further as to what sort of solutions we are building for the problem that we have on the hand. And we all love strawberries. So I was myself quite amazed as to how much effort a strawberry farmer has to put in the developing markets to make the strawberries come right to our table. And the project began with understanding some of those challenges and then trying to see as to how we can mitigate them. So I'll go on to the next slide. Okay, so what you see here are three beds of strawberry fields. The one on the top left is in Bali, much closer to Australia than India, where I'm sitting right now. And the other two are in southern parts of India, a place called Ooty or Kotagiri. It's in Tamil Nadu. Okay. Now, you see different practices in different parts of the world. In Bali, you could say that on the top left, the weed control is a bit more natural, i.e., you have a lot more weed, you see, okay? And but they have laid out the interbed. The bed is placed evenly, and interbed distances are fairly even. Okay. Now, on the other hand, in here on the top right, you have an open field plantation of strawberries, and you see variability in interbed distances. You see a lot more high density usage of the land area. Okay, so if you notice clearly, the bed in the first one has one plant per row, whereas here you have two plants in a single row. Okay, so on a single bed you have two plants, right? And provided you can manage them better, it is okay. There are different farming practices will allow you to produce as good strawberries on the second one as opposed to the first one as well. And then the third one, right here at the bottom, that is an indoor plantation. And basically, it's a greenhouse. It products, amongst many things, from birds as well. So birds is an issue, and but the disease load tends to be bigger in this area. So you see, strawberries are they grown on beds because they can't take standing water. If you can make out there's somewhat of a degree, maybe 3 to 5 degrees of incline in the beds, okay, so that the water, excess water drains off gradually. And then the beds are about a feet and a half, 2 feet tall, okay, and covered with mulch. This plastic here is called as mulch, okay. You see the plastic here called as mulch. In Bali, this was taken in a place which is about 1,500 meters in altitude, and they need to have greater temperatures, so they have it black in color here. Whereas here the temperatures are not as low, so you don't see as black mulch being used here. Okay. Now these strawberry plants are typically 4 inches to 6 inches, 6.5 inches tall. Yeah. And then the what's the challenge here? Now the challenge is that you want to detect diseases early enough. If you're able to do that, you can use less pesticides, less insecticides, and get done with that. That has a financial implication as well. Like in India, I'm aware that about 18 to 20% of the total selling price, not the profit, okay, total selling price of strawberries is actually coming from insecticide sprays. That's a massive amount. Yeah. So early warning helps you with that, and also helps you make sure that you don't have catastrophic disasters. Okay, the entire field or 70% of the field getting wiped out once in a while, typically once in 3 years to 5 years to 7 years, that sort of thing. Okay, so you want to do an inspection on a regular basis. Now, in developing markets, what happens is farms are not designed for automation. In fact, even greenhouse farming is not practiced very much, despite many advantages, plainly because the cost of recovery in terms of the interest paid itself can be quite high as compared to the selling price that the farmer is able to latch on. Okay. So they're not designed for automation. So they have a field, they prepare it to the best they can, and then they work with that. So as a result of which, what you have is vertical space is not well utilized. So you see here, for example, this is an example of a farm in Korea. This picture I've taken from the internet. I haven't been to this farm yet. Okay. So here you're having strawberries being grown on multiple levels. Okay. So you can keep going up, and you can have a rail robo, okay, go past this and make whatever assessment that needs to be made. Yeah. You already have the jigs and fixtures for that. So you can have a camera move around. Now, the little challenge, going back here, the little challenge is the early warning signals. They're quite small, really, 50 micrometer to about 2 millimeter. Okay, 2 millimeter is really getting on the other side of the early warning, but it's quite small. And the total height of this plant is, including the bed, is about 2.5 feet or so, a little between 1 feet 9 inches to about 2.5, 2 feet 9 inches tall. So farmer needs to really squat in the interbed distances. Okay, squat with a magnifying glass, observe the field, and when it comes to the rainy season, that operation needs to be done every second or third day. Okay, you miss it for 4 days. The fifth day, most likely, a farm is too costly to sort of recover, and in about a week or so during the rainy season, you might as well just abandon it. Okay, again, depends upon place to place, but these three areas, this is what the situation is. So it's quite a laborious task to squat and take a magnifying glass, observe, move on to the next one, and so on and so forth. Okay, so you keep doing that throughout the day, and it's a very painful task, right? So the idea was, then can we automate this? Now, if you have vertical farms like this, automation is straightforward. Of course, it is expensive, but if the farmer is able to latch onto that price, then automation is quite straightforward. And in fact, you might be able to benefit from reduction in the labor cost as well as increase in volume efficiency of the space utilization, right? So, but there's a ladder to climb. It's an expensive field after all, right? Because the early warning systems are so small, you can't really have a drone fly in the farm. I mean, you can have for specific cases, but generally speaking, you can't have a drone unless you put in entomological cameras, which are extremely expensive. So again, they'll price you out from the farmers that we're talking about in the developing world, from Indonesia all the way to large parts of South America also. Okay, so what we need is some sort of a ground mechanism to identify these signals. And the mechanism that we are proposing is to turn the phone itself into an early warning system. And when we talk about phones, we're talking about phones with €100, approximately 120 euro price. Okay, these are quite common with the kind of people that we're talking about. And they have cameras which are actually quite good. I mean, if you and I were to go out in the market and buy those cameras, they'll be a lot more expensive. The only reason these phone cameras are as cheap is because these companies are buying them in bulk, in tens of millions or hundreds of millions of pieces. Okay, the result of which you get fairly good quality camera, fairly cheap in price. So then it introduces other challenges. For example, here you can put in powerful cameras looking down from quite some distance, or you can have a more expensive system comprising rails and camera mounted on those rails, right? You could have those, but the luxury is you can have a processing done within the environment itself. But in our case, we need to make sure that we do the processing on the phone itself. In fact, the server cost can be too large for farmers. Here we're talking about processing several hundreds of megabytes of data on a daily basis. So transferring that amount is quite cheap, but interactively working with that amount of data on AWS type servers is quite expensive actually. Okay, so so the next level of challenge here is, once you build whatever solution you build, okay, then you got to bring it down to a phone and turn your phone into a early warning system. And this, in fact, system, once you develop it and you have the data set, you can utilize for many of these plantations where early warning signals are quite small in size. Now, going further here, just to give you an idea of what we're looking for. Now, this is a mixture on the top left. I'll go top row and then I'll come to the bottom row here. Okay, so thrip and dust. So thrips, when magnified, you can see them right here, right? They appear quite large, but they can be as small as 0.2 mm. Okay, and there are thousands of different kinds of thrips. Different ones colonize different types of plantations in different parts of the world. Okay, so the impact they leave is a slight browning of leaf, which progressively gets worse, and it happens practically all over the leaf. Okay, so there are diseases which begin, or infestations that begin on the boundary or at the petiole. Petiole is basically the stem that joins the leaf. For example, a little bit you can see here in this image, or you can see here as well. Okay, these are stems that join the leaf to the stem or the root, as the case may be, right? So different diseases begin at different places, but in here you have the disease beginning all over the leaf. Now, the challenge is in identifying these. For example, you can see a bit of the spots here, this one here. this one here, the corners, okay, which are thrip infestations, but they are in an early warning sense a bit difficult to distinguish from dust, right? So again, the dust here, if you are in a closed field, okay, you won't see much of dust. If you are in an open field like this, where you have a lot of weed growing, again, you won't see much dust. Okay, ideally you want an open field like this, right, where you don't have much weed, but the downside is you see a lot of dust in there. Okay, so you can subsequently bias your algorithms with that kind of information. But leaving that aside for the moment, so thrips are really small, very hard to see unless they're fully grown. By that time, it's too late. So what you want to see is not really the thrip because they're just too small from a phone camera. What you want to see is the impact they leave, the early warning impact they leave, and mainly the leaf on the leaf. Now, this is a subsequent stage where you see thrip infestation. I mean, this leaf here is now out of focus, but you do see thrip infestation somewhat here on the leaf as well. Okay, but you see it on the flowers, and two impacts it has is a change in texture. So I'm sorry, I haven't shared here images flowers which are not thrip infested. So perhaps bringing that comparison would have made this a much better representation. But leaving that aside for the moment, you see a slight browning of the flowers even before the fruit has come up. Okay, subsequently they do brown out and fall away, the petals here. Okay, but not in this phase. And you see a different texture in the flower petals. So you got to take my word for it. I can subsequently share with people who are interested comparative flower photographs that we have taken. Okay, so texture and changes in color here, they give you an idea that there is thrip on the flower. The reason I say we want to detect on the leaves first, if possible, is because flowering is for a much shorter period of time. The strawberry plantation life cycle is about 90, 95 days or so, the productive life cycle, okay, a single production. And the flowering happens over 10 days period. The leafing happens over a much longer period. Okay, so thrips are going to infest this a lot more than they'll infest the flowers. Okay. Then you have this aphid. Aphid is in here, okay, and these are again very small, up to about 0.2 mm or so. Yeah. So once you zoom into the right level, you're not able to see them with a great degree of clarity. And just like snakes, they mold their exoskeleton, and that's what you see here. The skin molds you see. Okay, so aphids tend to in the daytime cluster around to the joining points, the various petioles, okay, and go on the underside of the leaf, just on the underside. Okay, they don't like sunlight much. Yeah, so you do see a few here. So what you want to do is infer their presence from this skin shedding that they do. Okay, so therefore this is important as well. And again, you got to take it into account with the farming practice. For example, farmers that are very regular with their farm management, they clean these out, okay, much more regularly than they would otherwise in farms that are not as well managed. Yeah, so you got to take that into account to really get an idea as to if you see 20 of these here, what does that actually mean? Ultimately, you got to be giving a decision whether you should spray or not spray, right? Okay. So what does 20 of these in a certain area actually mean? That has to be contextualized to the farming practice. Nevertheless, the machine learning algorithms here will simply do the count. You will build an AI system on top of that for pre-processing as well as post-processing to contextualize the information. Okay. Um, Moving on, some other deficiencies. Now, I'll take this calcium deficiency first here. Yeah. So in here, what happens is it begins on the leaves again and tends to impact the younger leaves first. And younger leaves tend to come towards the center. So again, in image processing, identifying which are younger leaves is helpful. Yeah. And it comes up as reddish brown or purplish or yellowish brown spots. Okay. So again, along the edges. Yeah. Like you see here. So different from the infestation that you saw across in the case of thrips. And mites. So mites again cause browning. Okay. But this browning happens in the texture of this browning is very different. Okay, again, it'll happen all over the leaf, but you will see much smaller spots of browning, much less diffused, very well defined, as opposed to in the case of thrip. So you have different kinds of image features to extract and process in here. Now I'll come to this powdery mildew. This again can infest the entire farm within a few days itself. Okay, so in here, this is an advanced stage of powdery mildew infestation. And what you do really, if you have this stage of infestation, you just take the plant and discard it. Okay, so you don't want it to be transparent in the neighborhood. Now in here, what it does is it makes the leaves fold up. Okay, so you see the folding of the leaves here, as opposed to, say, for example, here, or you've seen here. Okay, so powdery mildew will cause folding of the leaves. Now in here also powdery mildew will do the same thing, right? This is at a much more advanced stage where in the underbelly of the leaves you can actually see the powdery, the white powderishness in the leaves. Okay, here you can't see it much, and the reason you can't see it much is because it's in one of the earlier stages. Now you get the same deficiency if you have NPK. NPK is nitrogen, potassium, and phosphorus. Okay, so how do we distinguish again here? So your machine learning system will be nestled between an AI system. What happens is, if you have had great sunlight over the past 4 to 5 days or so, it's highly unlikely you will see symptoms of powdery mildew unless you end up in a very advanced stage, in which case the plant is beyond rescue. So this is not an advanced stage. Here you can see the underbelly, but you can't make out, there's no visible sign, at least in the camera, that there is an infestation. Okay, there is if you look very closely with naked eye, but otherwise you can't really see that. Okay, so if you have had great sunshine over the past 4 to 5 days, you will not have this powdery mildew infestation appear here. Okay, so spraying will not really help. Okay, so oftentimes we can't distinguish whether we have powdery mildew infestation or we have NPK. So we need to bring that information from the farmer on a day-to-day basis. The farmer just enters how many days since excellent sunshine, and we take that and modify the decisions that we get from our machine learning model. Um, Going further, so these are some of the diseases or afflictions that we are looking at. Some are nutrient deficiencies and some are afflictions. Okay. Now, so what do we do? We gather data over a year. Data gathering is still going on, and because we have different seasons. So a strawberry life cycle is about 4 months, then it comes again, and so on. So eventually, you have the economic value of the plant is about a year or so. So over a year, you get something like 3.5 cycles or so. Well managed, probably you might be able to squeeze in 4. Okay, so it's between 3 and 4. So, but you have different infestations at different periods of time. So you get information over a period. And we've been doing it for a year now, and we've collected about 750 images. Now, this is I'm just showing you an example of infestation of the annotation. So we're taking the image and identifying various regions of interests, ROI, as you might have heard of. Okay, and to give you a full picture of the kind of region of interest that we're looking at, it's right here. Okay, so strawberry, whether it's a plant or a non-plant. Okay, so whether plant or flower or fruit or leaf, right? And then if it's a non-plant, then whether it's mulch or soil. Then if it's a plant, then whether it's a weed or something, right? So each of these leaves here comprise your final data set. So we have about 50 leaves in here. Okay, so this 750 images mentioned here, they eventually, we're still doing the annotations. They will come to approximately about 5,000, 5,500 images or so. Okay, clearly, if you have, for example, we have less of aphid infestation or thrip infestations. So we'll have less of those as compared to the other ones. For example, mulch is there in every image. You'll have a lot of those and so on, right? So we do that annotation. And this is the logic we are using to do the annotation. Again, the slides have been shared, and I'm happy if they are shared with the participants as well. So organizers may please feel free to take them forward with people. Okay, and I can answer questions subsequently on these. Now, once we do that, we do an augmentation. Augmentation happens at two levels. One is image level, which I'm showing here. Rotation is one of the things, and the blurring is the other. You can do deep blurring as well. I would not recommend that because that will leave artifacts which are a bit difficult to separate out based on the interpolation algorithms. Whereas artifacts left by blurring operations can be easily verified because you have the greater resolution data with yourself, right? So blurring is okay. Interpolation for greater resolution, I would not recommend unless you have some other ways of verifying the ground truth. Okay, rotation is clear. So you want to make sure when you're identifying an aphid or um, or a thrip, you don't confuse with longitudinal ratio versus the lateral ratios and all, right? So that's the reason why we want to do rotations. Okay, so these are done at image levels. Then there are more complicated ones. For example, um, we know how to blur, how to make changes for mites here or calcium deficiency, but I will not be able to apply a generic rule throughout because the impact it starts having is different for different parts of the plant. Okay, so for example, older leaves, you see more dark purplish hue as opposed to bright reddish brown or light purple hue. Okay, so we don't want to do data augmentation and end up in a situation where we have unnatural features crept in. Yeah. So similarly, there'll be some features which we might be able to apply on, for example, the strawberry itself or young strawberry fruits as opposed to the more mature ones, right? So you want to take them piece by piece and apply them accordingly. So that's what I mean by doing image level, which is the entire image you have, or doing region of interest level data augmentation. And then we built two models for classifying. And so this is based on, roughly speaking, 400, 450 annotated images with regions of interest, something of the region of about 2,000, 2,500 images. So more work needs to be done. Now, again, we won't go through the details in here. We took a RESTnet which was available on the internet, and we modified the RESTnet for our problem. Modified meaning we kept the architecture the same, but we changed the way we are dropping out or how much dropping out we are having in between layers. Okay, and we were able to achieve reasonable performance. I'm not getting into the performance measure here right now. Reasonable performance with 98 megabyte of uh, we then developed a bespoke deep CNN model, which we were able to fit in just 5.7 megabyte. So 98 megabyte versus 5.7 megabyte. So this can make a huge difference to the application size. If I have if I have €100 phone and half a gigabyte application running, most people will not want to use that. So that's the reason why a much smaller one is preferred. And also you can have a much better throughput rate there. And part of the reason we believe we've been able to do much better than ResNet here, in the sense of getting about the same accuracy, but much less memory, is mainly because that we are using limited amount of data. So, but on the other hand, if you look at it from a farmer perspective, the farmer really cares about data that is contextualized to his or her farm. The farmer doesn't really want to bother about global data sets. So there is some merit to using less data, getting more accuracy, but getting a much smaller neural network in place. And the bespoke deep CNN, basically, it has many multiple layers. Again, if you zoom in, I've shared the image in very high resolutions. If you zoom in, you'll be able to see these. You'll be able to read what has been written here, but I'm sorry, I won't be able to show it to you here. Okay, so this has been the classifiers that we've been using. Now, going further, I want to leave a thought here, which we are working on right now. So basic idea is if you see the images, top row first, and then the second row, again going from left to right. Okay. So if you see this image here, and again this has been shared in very high resolution, you can take a look, zoom in yourself, and make sure you're comfortable with the analysis presented here. So you're going top row left to right, and then we'll go bottom row left to right. So all leaves appear to look healthy. The idea is that if you're not able to distinguish as a human being, highly unlikely you'll be able to develop an algorithm which will be able to distinguish. The main reason is you will have a poor signal to noise ratio. Okay. So secondly, what I can do is I can have my filters, right? So we work with convolution filters in deep CNN, and those filters can be very large in size. Or if I'm restricted by the algorithms that I pick up from the internet, I will cut up the entire image into very small pieces and apply it on each of those. Okay. Now, when I do that, it'll be a very slow algorithm running. Okay. Typical filter size, I think it was mentioned in the last discussion as well, not in per se in terms of filters, but we were talking about 512 vectors. Okay. I mean the same thing, 512 by 512, or 256 by 256, or 224 by 224. Okay. And these images are about 8 megapixels or so much more resolution. So, well, you can't use convolution filters which are very granular, but then you might miss out. Okay, so if you go speed up right to the end here, you can see aphid exuvia, but you don't see that here, right? So the idea is just like a human would. If you don't see it here, you will tend to zoom in. Okay, when you zoom in, again, there's a probability of assignment of classes. You will see if that probability goes up beyond a threshold. Okay, or remains below a threshold. So there are two thresholds you require here, but if it is going up beyond a threshold, you will zoom in still further. Now, when you zoom in still further, just like a human would, you would focus on regions where zooming in has given you, or is likely to give you, more information than otherwise. Okay, so that's what. So you can ignore the rest of the things. So you will compute a region-wise probability of the information gain if you zoom in. Okay, expected information gain, right? And if it stays below a certain level, for example, in this part of the picture, it remains below the certain level, we ignore it entirely. Okay, so if it remains below a certain level, you ignore it. If it goes above a certain level, then you actually zoom in further. Okay, that's what a human would do as well, right? So this is multi-layer attention neural networks we're talking about. Okay, and then you start seeing something, and then you're seeing a monotonically increasing expectation of some information gain here. You zoom in further and you almost see it. Okay, and in here you get the morphological features as well, because these are skin sheddings, and the aphid actually has legs as well, just like many insects do, and antenna. Okay, so these are not smooth sheddings, but they do have some morphological features which now you can make out. Okay, so just like a snake skin is much bigger than the snake itself, once it sheds the skin, right, then it's much more looser. And same is the case with exuvia. The aphid exuvia is actually much bigger than the aphid itself. So you utilize that information to actually check whether you have aphid or not, right? So you see the features and you have almost 100% confirmation that you have some degree of aphid infestation. Okay. In fact, you can see one aphid, live aphid right here itself. Okay. So we're building on this neural network. Perhaps next time we'll report on the results of this one. We haven't finished this yet. Okay. Continuing further. Now, one of the problems that we did see is that when we're doing this multi-level zooming, we talked about having two thresholds and working with those thresholds, things which do not improve in information gain, uh, and the information gain remains below a threshold, will leave them without zooming further, and things which continue to improve or go above an information threshold will continue to zoom in. Okay, so that we can be efficient. But there's one more area where we can increase the efficiency, which is getting rid of the background which is irrelevant to us. Or for example, right now you don't see many fruits, but during the fruiting season you will see perhaps 3 to 4 of these jetting out. Okay, or flowers in there, right? So if you're looking for problems in leaves only, or clearly we're looking for problems in the strawberry plant, right? Then we can ignore the bed and the mulch area, and that's what we are trying to do here. So that's the other bit of efficiency. Again, so this is an outcome of the algorithm I'm showing you. It's been trained on scarce data, only about 50 images or so. So there's a lot more optimization that needs to happen. Okay, but the general idea is we we have this information. We use Photoshop to manually mark the region of interest, like you see here. Okay, and once we do that, we're using unit architecture. Unit is utilized quite a bit in all of these automated algorithms you see online for background foreground separation. Okay, so we use this mask to train a data, and then we get a predictive mask like this one. Okay, so eventually you have this so ground truth in the sense that we have said through our own handwork and Photoshop that this is the plant and this is the predicted value you see here. In fact, it does a better job than otherwise on areas which look similar. So we said, for example, this is the plant itself, even though that is not correct. However, because this area here matches the background area a lot more, it's able to identify and strip that out, and you could see it there, right? So, so we're working on improving the efficiency of this algorithm. It's mainly to do with the increasing the data set that we have available. And again here, so you see another image example, and you can see the impact here. This is the actual image. This is the ground truth that we constructed in Photoshop, right? And here you have the predicted mask, which is again following the actual plant better than the ground truth that we labeled with hands. We were a bit lazy out there. Okay, and again, the reason is the same. So for example, if I have a leaf which appears quite like a dark shadow, then chances are that that'll be misinterpreted by the algorithm as compared to the hand-drawn one. Okay, but if you have a clear distinction, it'll be very easily made out. Now, this is also very important in the sense that oftentimes I don't need to tell how much is the damage, but how much is the damage relative to the plant size, or how much is the damage relative to the number of fruits or number of leaves or number of you have flowers in there, right? So background, foreground extraction is really essential for that purpose. And in addition to the algorithm that we were just talking about, where we were doing multi-level zooming. So multi-level zooming, just to give you a connection on how much time it'll take. And we're building up to 6 levels of zooming, again, on limited data set. So I'll not emphasize the number 6 too much here right now. But basically what that means is whatever work we're doing here in this algorithm, that's a bit, give me a second. Let me just see where that is. Yeah, whatever work we're doing here, the amount of time needed will go up by roughly about 6. So he said we don't want it to go up roughly by about 6 or so. So we want to do the background foreground separation and then work only on this area. Okay, so that's the reason why we're doing this thing. And so that we can get a probably within just a factor of 1 explosion, we should be able to get the same amount of information which we would have gotten otherwise by going through a very step-by-step but inefficient process. Okay. Now, this is again background foreground separation. We covered it. Some more examples here and some more examples. So you can see, here the white part here may be confused with again the background here, but we are able to detect it properly. And this white part is residue. So it is treatment residue. Again, pesticide being sprayed. I don't have a picture here, but it's sprayed as a fountain from about 3.5 feet height, and that's done regularly. So it leaves these white spots in here, which have nothing to do with the plant issues. But nevertheless, we wanted to make sure that we are able to distinguish leaves in this situation also. Okay. So now we're using unit. The reason we use unit is because everybody's using unit for background foreground separation. Again, we won't get into the details as to why it works, but I'll just go over very briefly in the limited time I have available as to what is the operating principle here. Okay, so what it does is it continually maps the feature vectors. It extracts the feature vectors first. Okay, from again, we're going left to right. Extracts the feature vectors with higher and higher features. So you see the convolution maps are reducing in size. Okay, and then does the classification once it has abstracted highest level of features. Once it does the classification, because we don't want to be just told that this is the background, this is the foreground. We want actually that to be mapped back to the original image that we received. Therefore, it goes back to reconstruct. So here you see, actually the job is done. If you only wanted to determine in a mathematical sense that what is the background, what is the foreground, you might as well, just like our previous speakers spoke about the information being represented in terms of numbers, in terms of vectors, as opposed to what we perceive when we are interacting with ChatGPT, is the same thing here. If you just wanted to bring out the numbers, you could have stopped here. Okay, but you're willing to take some more penalties in the errors that are going to creep in the reverse process. So it's basically bringing the process from here to here, and then it's reversing out this process. Okay, so it's taking, roughly speaking, double the time, and it's roughly speaking doubling the errors. But because we want information, as in we want this as the output and not a bunch of numbers, so we don't want to be reconstructing those things or reinterpreting those ourselves. Therefore, you have whatever you're doing here, by and large, you're reversing those operations aside. Okay, so that's how a unit works. And similarly, that's how a squeeze unit works. So a unit is taking 16 MB. A squeeze unit is taking 10.3 MB. So you had another one, which is for classification, which was taking in a raw basis, roughly about 2 MB or so. Okay. Again, we need to go through some rounds of improvement, and perhaps we'll be able to stick this in within about 20-25 MB, which, by the way, is a reasonable chunk of memory that you will pull in, because when the farmer is actually taking photographs, each photograph we saw useful level of resolution is about 4 to 8 megabytes. Okay, so processing these within, so again, you have algorithm space, you need space to maintain the photographs, then you need to keep some history, because farmer may want to cross-check some outputs versus what the algorithm gave as an output, right? Okay, so that's how your application keeps going up in size, and you want to make sure you can run it on phones that farmers in the developing world can afford. Okay, so that's the reason why. And if you have farmers who have fairly rich phones, for example, they're carrying iPhones and all, it's not a problem. Then they can detect the early warning signals even before time, or they can detect other varieties of problems which these phones might be limited to. Okay, so here, this is where we end. And so again, to recap, what we have covered is the reason why we want to do an application on a farmer's phone, why we are limiting it to 100 euros, roughly speaking. Then again, we went in through two different models. One is ResNet 50, other is Deep CNN that we crafted out ourselves. Okay, two different models for estimating the various challenges you see, the afflictions or the diseases, as the case might be. Then we talked about increasing the efficiency by zooming in at different levels and taking the decision accordingly. And then finally, there is one more bit, because when we do that zooming in, we have to do multiple passes. Therefore, we want to get rid of information which is irrelevant to the pass. And background, foreground separation is one clear example of irrelevant information, i.e. the background there. And we talked about two models for actually getting rid of background, where we talked about preparation of the data set and then utilizing that data set to train our own model. And it's giving you, so the SqueezeNet, it's to the credit of the SqueezeNet model, really. It's doing a fairly good job just with a few hundreds of images that we were able to supply to that. So I think I'll stop here and wait for questions.
Thank you, Dr. Amit, for the insightful presentation. It's quite fascinating to see how machine learning can be applied to agriculture. Would like to welcome any questions from the audience. If there are any questions, please let us know. Otherwise, I would just like to ask you one thing, Dr. Amit. Because we are applying a lot of technologies, machine learning, image processing, etc., to agriculture. Would you kindly elaborate on a specific challenge when it comes to, applying these technologies to agriculture? Was there any such challenges that you might have faced?
Right. So the biggest challenge that we are facing is the data itself, and the data can be quite different depending upon which place you're talking about. The thing is, in academia, you see publications which are trying to solve problems where when you try to apply it on the ground, you see the farmer cannot connect to those problems. So a lot of this work has already happened, and improvements are happening as well, but they're happening behind closed doors because there's a lot of commercial value to this kind of work. So what ends up happening is the farmers in the emerging markets who do not have access to, or even in Australia, for example, I mean, if you're a small farmer, you may not be able to get in touch with Siemens for a solution or other large companies that are making that. Alternatively, you might be able to work with bespoke solution providers, but for some reason, I'm not sure, they are not large enough in the sense that they don't cover large parts of Australia. So the cost they charge is high simply because they work with a few number of clients. So it's really out there when you go and visit multiple farms in different countries, you get to know the problems and you're able to contextualize that information. So contextualizing the data, identifying the data that you want to collect, and then structuring the problem in a hierarchy to solve, which is all basically non-publishable pre-processing work. That's the biggest challenge, and it's time consuming. The other bit, again, from an academic or small company perspective, I would say is getting the talent for coding things on a phone. Efficiently coding is hard. So making apps is an easy problem now. You can get enough people, but making neural networks run on the phone or operate in a federated learning fashion, in the sense that I'm a farmer here and there's a farmer 30 miles away. Okay, there's a lot of similarity between the issues that we see on our farms. Okay, can we actually, instead of having one gigantic model run on all the farms, which again is going to consume a lot of memory and computing power, can we have many small models, different models perhaps, which automatically learn? So right now we don't have a learning mechanism which is online. This is just a classifier, right? Learning on the farm is a bit of a challenge, and getting people to efficiently code that on so that it works on the phone, that is the other challenge that I perceive, which comes in the way of commercially implementing these solutions.
Thank you so much, Dr. Amit. Yes, I do agree. Developing some theoretical solutions, it's one thing, and practical implementation, it's a whole new challenge on its own. So, yep, thank you very much for this insightful presentation. Now, I would just like to announce that for external participants, it's end of session 1 for the day, but those who are enrolled in our DEng program, they could proceed to the room for the student presentations to listen to what their peers are presenting. So, yep, the students enrolled in the DEng program, please proceed to the student presentation room using your guest link. Thank you very much, everyone, for your participation and interaction. And thank you so much, Dr. Amit, once again, for this really interesting, fascinating presentation. Thank you.
Thank you. Thank you for having me here.